Actually, if you look at the ICT market in Pakistan, it was growing. It is growing from the last 10 years, growing in a very good double-digit growth there, and it is sometimes it's more than 20%. And still, even although it was being considered that 2010 will be a negative growth and 2011 will be a positive growth again. So it's Pakistan as an ICT market is still growing. 2010 was overall a bad year for the ICT market, but it was not that bad. So we see that market have still a potential and still have strength to grow, and there's a lot of opportunity available, because if we look at the infrastructure presently available related to the information technology, it is 10 to 20%, and the availability, although in cities the ICT infrastructure seems to have grown to a bit, but practically if you look at Pakistan as the biggest scenario, so there's a lot of potential still available to there. And the international, even different reports, even IDC is also expecting that Pakistan market, ICT market will grow at 10% in 2011. Yeah, actually, there are two things. Actually, when we talk about companies like us, and we're going to talk about data center, there are two things. One, when we cannot say generation, because we mostly deal a product called UPS, which is uninterruptible power supply. So it is not a power generator, it's a power accumulator. And the major role for that product is, it is a protection device for any sophisticated equipment, mostly the IT equipment. They require continuously clean power. So that's the one thing. When they required a continuous clean power, mean they required a secured power source to them. So that's the first source when people contact companies like that. Then how the market is growing and needs are changing. So right now the most required need for the medium and large corporations are, and sometimes small corporations are, the data centers. In data centers there are several aspects, because it required a server farm. Server farm means they require a lot of computing equipment there communication equipment there. So in a data center there are 4 infrastructures required. One infrastructure which is the base, and base is including to a physical infrastructure, mean a civil work required, and then the first layer of that where they have to house all their equipment, that means racks, something like that, which the equipment available. Then the environment which is required control temperatures, and then communication infrastructure, and fourth one is the ICT own your servers and things like that. So for us, we are linked with the physical critical infrastructure, which is covering which can provide them a space to housing their equipment, control the environment, power management and power distribution, and cooling. When we say cooling, cooling can be used in the wide area, but this is specific to, you can say, heat removal from the data center site or heat removal from IT equipment. And because IT equipment will be run on a specified humidity level as well as on the temperature level, it is totally different from what we require as a human. So needs are different. If we look at physically, it can be, it's calculated and it can be feel by themselves as well. Two important things are, when we talking about power protection solution, the UPS side, and when we're talking about the cooling or heat removal from the data centers, these are the most common components which utilize energy by itself. UPS by itself don't consume the energy. Energy is consumed by IT equipment, communication equipment, complete ICT, what you can say IT fabric. So IT fabric consume the energy, and the waste is heat. So now they required one source of energy to run that machine, and they required another energy to remove that heat from the data center. Where comes the cooling? And as right now we've seen, things have been changing in information technology. Initially people are talking about the availability, and they are managing the availability. Right now they are managing their energy bills, because energy is not only scarce, but it is also expensive as well. On the other hand, one way is that we can produce abundance of energy, which we cannot, because the sources don't allow that. Let's say we can do that, but when the cost is occurred, it is then becomes so costly that business not become viable. So now they can only own two things. One, we have seen that we produce, which is not solving the question. Other is that we utilize it efficiently. What is available, use it in a way that is being produce more output, and obviously save you from the cost side. So that is actually the crux. And on the data center side, the need is grew because data center has to run 7 into 24 hours into 365 days. So that is one area in any organization which will consume energy all the time, all the day, because they don't have to shut down, at least tier 3 and tier 4 data centers. So in that way, what we will do that we have changed how the data centers been designed and they've been installed, and also there is a lot of improvement in the component side, so which reduce the consumption of energy. And if I just give you one figure, it will reduce especially in the cooling side, because the major bill is the cooling side. And if it is not efficiency in the UPS side, it is actually also edges up into the from the cooling side as well, because as well as if the electrical equipment is inefficient, it produces more heat. So that means on both ways you are losing money while equipment is inefficient by itself, and it is giving you more energy bill. On the other hand, it's producing more heat. So that means on the other hand, you're also putting more energy to removing that heat from that area, mean more cooling putting onto that. So by using an efficient and what you can say, plan it wisely, make your data center more efficient and reduce something around 40% of energy, especially on the cooling side. We can say just for in the data centers, if you see, we can say a medium-sized data center, electricity bill is ₹500,000 Pak rupees in a year. So generally it is around that, and it can be reduced down to 40%. So you can have an idea, it will come to 3 lakh rupees in a year. So that can be done. So on percentage, you cannot, on the total electricity bill, you cannot manage that, because it's depending on that where they're housing their data center, what building they are, and what is the occupancy of the other buildings are, if they have, how many employees and how they are working on. But generally, from the inside the data center, we can give you the figures on these things, and actually we made it more simple for the people as well, because these efficiency calculators are available on our website. And from them, they can give you the calculation, they can put on their own data. Right now, I'm just giving you a guesswork, but they can put their original data, and it is not related to our equipment. They put their own data, their own numbers, and they can find out that if they even, just change a layout for their existing data center, they start saving money on that. Not even changing the equipment. So it's the design which matters a lot. On the other hand, now, how they plan, that is also very much important, because previously data centers are being designed by thinking of the room based design. So I can give you an example right now, like let's say there's a bank who has required something around 10 racks today, and each rack is somewhere around 4 kilowatt of the load, and they're thinking of that they will grow 20% next year, and they add 2 more racks, and they're thinking that next year they grow 30%, so they goes up to 15 racks, and 15 racks 4 kilowatt load they have planned today. So they have to now plan for a complete room. So they will buy cooling today for that purpose, power protection for that person, and maintain the environment for that. And previously we have only one option available in the past, that is that to cool the data center we use normally the raised floor. And raised floor actually have a plenum beneath them, where we have to make a balloon of the air, and that balloon is maintained by obviously a cooling unit inside, which have larger fans which are running 24 hours 365 a days and maintain that pressure. And from the raised floor we call perforated tiles which have holes, from where we can bring cold air in front of the racks. So that is the normal way of doing the things. So when we plan the room initially, so that means if you have a larger room today, and because that room was being selected from the future growth, so you required larger machines, larger fans which are running all the time, and try to maintain that balloon, cold air balloon all the time, which can provide actually cooling to your cooling equipment. So this methodology is have a lot of inefficiency by them itself. On the other hand, this rack load, it is also changing, because there were low density racks in the past. Right now technology being changed more towards consolidations. So now, and the better utilization of the space in the rack. So servers in the past, if you see a server which is actually have a computing power, this for let's say 100 people, was the size of 5U 6U Right now, for 1,000 people, you can find a server. We can, run different application, different work for you, and it come under to one view. And when we're talking about blade chassis, so blade chassis can do a, system which is previously installed in a whole room. Now you can put into one rack. So now by these things, improvement in technology, we have seen that, and better utilization in the space, the load in the rack has also been increased. Now it's safely, when you are using blade chassis or blade servers, so it been 8 kilowatt and even up go to 20 kilowatt a rack. So now two challenges comes with that. You require more cold air to cool them and more airflow to them. So in IT equipment, two important things. One is the temperature you have to maintain at 220 to 22 degrees centigrade. That is ASHRAE guideline, and ASHRAE is actually American organization who give the standard for the cooling solution, and it's also have a local chapter in Pakistan, so people normally follow that. So it's an independent organization. And then they also have to maintain 50 to 55% humidity level in the data center room. So to maintain that environment, so you require a lot of cooling power, and you require a big raised floor, because to maintain that airflow in front of the rack, because which helps to take that cold air into the system, you have to maintain that, so you require more air. So generally data centers guidelines for are under either the Uptime Institute or the TIA 942 standard. So I just give you the example of TIA 942. So if you have a 6 kilowatt rack, and we're talking about now 8, 12 and 20, you require a 4 feet high plenum, 4 feet high raised floor. And you can now imagine it's just 6 kilowatt and it is moving to upwards. That means if we move above, they probably talk about a 6 feet high data center, and then you can imagine that how much air pressure we have to maintain and how much energy required to maintain that. Even after that, when you have a raised floor and perforated tiles, it is not easy to maintain. It's very difficult to maintain the airflow which is required for the machine side. So generally, if you have visited any data center today, you will enter into that, you will find out that it is almost chill and you cannot stand over there. But when you go to near to the machines or the racks and you put your hand inside the rack, you will probably can fry an egg onto that. So normally there's a failures, unseen failures because of the heat. People not understand at the first place, but their vendor or their supplier or service provider come in and tell that your server failed because it been starved by the cold air. So that's the big challenge. On the other hand, raised floor is also a big challenge. Energy is the big challenge. So that's why actually with the lot of research, we actually change the methodology of the cooling. So we bring the cooling unit near to the heat load, and that's we called that room-based cooling is called, generally the technical name is the perimeter Persian cooling. Although Persian cooling and comfort cooling also required some explanation, but it will take long time. So I just giving you the Persian cooling, which is actually generally to understand that Persian cooling meant for the IT equipment, and comfort cooling obviously for the person. The difference, major difference is that Persian cooling mean 99% sensible cooling, and on comfort cooling there is 50% sensible cooling, 50% latent cooling. And when we say latent and sensible, that means it's not the other one is the idiot cooling is there. But the only thing is that the difference is that latent cooling can change the matter actually different forms there. So from water to ice. So it required more energy into that. IT equipment, you required only the cold air and maintain the temperature. You don't have to change the form of the matter. So that's why it's a 99% sensible cooling. So that means when they're producing 99% sensible cooling, saving energy. While on the room side, when we're talking about the room-based cooling level, the problem one that we have to put more energy to bring out more airflow, and then it's also their limitation because we cannot produce a lot of what you can say airflow with the perforated tile, because if you see it's a balloon maintained, how can you increase the raised floor? Probably you have more perforated tiles in front of you. That means pressure drop in one area, because if you have one area where you required more cold air, probably you have more perforated tiles there, and the other area will be starved. To maintain that, that means you have to put in more and more cold air and then the energy like that. So to come over that, we come up with the idea that we bring like a rack, we bring a cooling rack near to them. So now generally IT equipment take cold air from the front and blow on the back. So when we put cooling unit adjacent to the rack, so when cold air blowing in the front of the rack, and when it goes out from the back side, it will be hot, it will be captured by the cooling unit in the same row. So you don't require long panels to which or long path to recover the heat, and on the other hand, to blow the heat, it is blowing vertically in front of the rack. So they have the cold air nearer to them, and these fans are now focusing only to providing cold air to the rack only, while in the room based structure, despite of the other factors, the other thing is that technically the problem is that you are also cooling the room, so you have room load there. So that means the things like a very perfect example is the refrigerator in your kitchen, because you have to keep cold, let's say meat, ice, something you want to make ice onto that. So you have a refrigerator who have a cold space into that. You never cooled your kitchen to that because you want to keep safe of your things and you want to freeze them. So you cannot freeze your kitchen. You only have a refrigerator. So it's a similar way. When we have room-based cooling system, actually we are cooling the room. There's a lot of room and load into that, and then we are wasting energy onto that. That's one element, despite the other technical factors. And when we're talking about the row-based or the what you can say rack-based cooling, it is now focused, and there are sensors which are linked with the nearest machines, the IT equipment. So they are working with them and they are providing cold air and maintain the cold air for the IT equipment. So that's how it is saving 40% of the energy, because it is cooling, providing cooling where it is required. On the other hand, design is modular, because design is modular means that you are not planning the room today, you are just planning for the racks today, and when you add on, you can add on more racks to that. So similar goes for the power protection solution, that for if you require 100 kVA UPS today and it will be go to 200 kVA, you don't have to buy 200 kVA today, you have a 100 kVA solution today, but it is modular and scalable and without any much efforts. Later on, if your data center required more, you can add on more power into that without disturbing the present operations or the infrastructure to that. So that's been whole idea, is to more scalable and pay as you go approach. So that's how you are saving your capital expenditures and then operating expense indirectly, and directly it is impact on the return on investments. So it is being measured, calculated, and is in front of everybody. Concept is conceptualized at that point of time. As in being an APC, we are focusing on the power protection and data center side, but Schneider is moving towards green, and now it is called not the green building, it is now called intelligent buildings. And if you look at Schneider logo, it is green because our objective is to save 40% of the energy consumption, and as because it does have other hazards as well. So at that point of time, involvement is very much required, because when we are planning a building, so you have to plan everything. It's when, as we talked about a cooling need and power need for the data center, is similar for the from the building perspective side, user perspective side. There's a lot of things can be done at that point of time, like I said, that energy management, lighting management, and generally when BMS was a concept, and people are thinking generally when we talked about previously in the BMS, building management system, the HVAC management, it is there, but it is now much improved. Even now, you know, it's been system being designed and designed by us and the other people as well, that, you know, when people enter in the room, lights will be there. Even light intensity been changed depending on the requirement from the outside. Mostly design have to be, except the data center, when the system in design should be rely more on the sunlight, and sensors being planned in a way that they are just the inside light as compared to the light changing outside. Similar goes for the cooling side, your lift elevators usage, way how they consume the energy, any electrical equipment and socket available which are in the building used for other electrical appliances, source of the electrical appliances. So the nutshell summary is that at the initiation level it is much required, and these are called now the building management system, which is actually been planned at that time when they are conceptualized the building structure, and designed also been maintained at that point of time, and overall it became make an intelligent or a green building which can utilize energy more efficiently, but providing you more comfort and more output. We are growing although 2000 was not overall a good year for Pakistan economy and for the IT environment, but somehow we are on target as an APC. That was good sign for us, and we are still see there's a lot of projects in the pipeline where we're working on as an APC, as a Schneider. That was amazingly very good year 2007 for them, especially people realized the need for this green intelligent buildings, power protection solutions, efficient data center, and what you can say the nutshell or we say the core word is efficiency into their system, which is actually directly impact their ROI. So right now our objective is, and we are working towards to making the organizations and efficient enterprises. So as a whole, which is considering IT and IT fabric, energy, environment, so all that. So the word we use is the efficient enterprise for them. I am Munib Khawaja, VP IT Business for APC by Schneider Electric, and you are watching me on CIO Web Studio.